Okay, so today class is a little bit of a transition between the topics which we had so far and the new topics which we'll have from next lecture. So it's a little bit of Java refresher and a little bit Android, and it's a bit of a mixture. So if you look at the schedule, you will see that we have a well-defined plan for the next 3 sessions. And our today's session is kind of a little bit outside of the normal flow. So this is an extra session which we have for introducing some extra things which either changed from last year or to help you with some of the kind of new material that you have learned from the previous lectures. So from time to time, we will kind of do this catch up. I want to highlight that for the next 3 lectures, there will be no actual lecture. So there are lecture videos, which I encourage you to watch, and they are good in a sense that you can speed it up. So you don't have to listen to me in the normal pace. You can watch them faster. Some of them you can easily watch twice the speed. So I watch all of those lectures, and there are small things which I have to comment on, but most of the material is kind of exactly the same. So all the code examples and all the Android Studio examples that you will see on the lectures recorded are kind of applicable now as well. So the first one is quite, it is a combination of generic lecture about UI and design for the mobile, plus some coding things about XML. We will spend a little bit of an extra next on Thursday, going into some of the small differences, right? So if you could watch it before Thursday, that would be helpful. This one is a generic lecture about background on mobility, very non-technical, although there is a lot of engineering information about various standards and how the telecommunications kind of evolved to the state that we have now. It doesn't have a strict relationship to programming on Android, but it's worthwhile to understand some of the principles. And then this one is quite hard. So this one I watched the 2 hours of exercising of threading and the way you can update the UI. So I encourage all of you to watch it, and I'm pretty sure we'll have. Yeah, sorry, that's not useful. Could you turn the other screens, please? Okay, so to repeat to those of you in the class, we have today we have like a transitionary between the topics. Then we have the UI topic, and why do we use XML for Android UI development. And a little bit about the layouts. So some things will be updated. The lecture is fine, but we will update some things a little bit. So next Thursday we'll have like a Q&A session, more practical session, and bring your questions with you. So watch the lecture before the class, and then in the class we will just answer questions and do a little bit of a practical things. This one is the more theoretical one. About the telecommunications and about the telecommunication standards. And this one is about concurrency on Android. This one is a little bit early in a sense that we haven't covered asynchronous tasks yet. But what we will do today, we will cover some of the threading, and then asynchronous task will be one of the methods which we can use for dealing with the background services. So that there are 2 topics. So one topic is background services, and the other topic is a UI. In both of those topics, you need to know about threading and about how to work with background threads, right? Last year, what we did, we talked about asynchronous tasks more from the services part of things. But I think logically, it should belong to the UI. Because you're not supposed to really use asynchronous tasks for dealing with the background services. You should rather deal with the UI updating. So we're kind of transitioning it. So that's why this topic comes first, because it is related to the UI topic. And then Christopher will talk about background services and services, and he will talk about asynchronous tasks again, but in the context of background tasks. And we will talk about why you're not supposed to use asynchronous tasks for a long-lasting background services, right? In the service lecture. So what I will do today is kind of like a little bit of a preliminary to this class, which we'll have in 10 days or so. And it is also a little bit of a catch-up of where you are at the moment with Android Studio and with the intents. So last session on Thursday was practical session, and most of you did some practical work. So what we will do today is also a little bit practical. I will be talking using Android Studio, and most of the things are related to Java. So they are not related, strictly speaking, to Android, but some things are Android specific. So I will talk about the Android specific things as well. So let's start with, and I encourage you to follow as well. So, fire up an Android Studio, and we will do a simple thing. So generate a Hello World application with Android Studio, like a completely new project, and run it in the emulator. So you make sure that you can just generate similar what you did on Thursday, okay? So what I will do, I will minimize that a little bit. And I will say I'm starting a new Android Studio project. I will pick a basic activity. Next, I will call it basic Java. I will change the package name slightly. Okay, so which version of API should you target? It doesn't matter. If you were to develop an application that you want to release, you would kind of look into the help me choose, and you will see that if you target 4.1, you would cover almost 100% of the Android devices. If you go a little bit higher into KittyCat version 19, Android 4.4, 95% of the market, right? So it kind of depends how much you want to be backwards compatible and how much you want to use the latest APIs. For the exercises and for the labs, it doesn't matter. You can use the latest one. You can use the 8 or even 9 if you want. What's wrong with choosing an earlier one? Well, you don't have particular APIs, right, which were introduced later, right? So if you want to do something like particular transition, animation transition, or something that was introduced in 6, and you're targeting 4.4, then it's not there, right? Then you can only use what is available at that particular API level, right? And you remember that we have the API level, which is like a continuous integer, and the kind of the platform version, which is a more human readable versioning with the name, which is following the kind of the letters of the alphabet. So we are up to version 9.0, which is 28, which is called Pi. That's the latest one available. So for this one, I'm choosing API 26. It doesn't matter which one you will choose. You should choose the one which your phone supports, right? So if you have an Android phone which supports 8.0, you should not build your app for 8.1, because then you cannot deploy it on your phone, right? So pick the one which your phone supports, because then you can run it on your phone for testing. You should take this project will support instant apps. It is easier for yeah, it doesn't matter, just take that one, and then you finish. It will generate the skeleton, build it. And as you know, internally, Android Studio is using Gradle, which is the build tool for Android. We don't need to read the tooltips. And it checks all the dependencies. It checks what do you need to run the project, and it pre-compiles it. So it kind of it also manages the version control. So it automatically says, I'm gonna put all those files into your version control, and you don't want that. So you say none of those files should go into version control. For the normal assignments, you want to version control all your files. All right, so first thing that we will do is I will kind of check with you kind of action handler, okay? So if we go to the code, okay, so let me just run it so you'll see how it looks like. So I have 8.1 emulator, which I will run. Keep it here. Is the font too small? Yes, the font is too small. Let me go to the code. So this one, big enough? Yeah, this one, okay, this one I cannot easily change, I think. Let me see. No, I have to change it in preferences. So menus and toolbars, appearance, font size 24. I don't think this one is this one. No, it's not. This is the editor fonts. Yeah. I don't know. Let me see. Oh. Okay. So is it possible to change the font size for the project panel, which is the one on the left, the top rated answer? Yeah, no, it's not possible, unfortunately. Settings, preferences, appearance. Okay, maybe. So settings, appearance, let's see. Yeah, appearance. I don't have it. Override the full font. Where is it? This one. Okay. Yay! Great, thanks. Okay, so this way we have slightly bigger fonts. Is it fine now? Better? I can make the fonts of the editor. This one kind of big. And this one, yeah, we can change even a little bit more. Okay. Yeah, so I'm under Java, the package that you've generated initially, and main activity, right? So let me just make it a little bit bigger this way. Okay, so what we have here is the main activity, and if I run it, so if I press run and I pick my emulator, it will start here. So it will build and then start, and then I can see how it looks like. And it will have a kind of a toolbar at the top, the content pane for the actual content of the activity, and the action button, which is on the right lower corner. So this floating action button is called floating action button, and we are kind of referencing it here. So this is the line of code which references the this floating action button, right? So yeah, and the app looks like this, and the floating action button is here, right? So I'm grabbing the handle to this floating action button, and I'm registering a handler which will react to me clicking on it, right? So here, if I expand it, I have a new view Onclicklistener, which implements an onClick method, which passes the view on which I clicked, and then it generates a new snack bar. So on Android, you have two ways of doing a very quick messages to the user. One is using a snack bar, which kind of looks like this. It's sort of a bottom of the Android kind of slides up, and then you have some text. You could have potentially some icon, and it hides. And how long it shows up for is dictated by this parameter here. So currently, if I click, it shows up. It's up for like 5 seconds, and then it disappears. If I change it to short, and rerun it, so the app has restarted, and now if I do it, it's up and down a little bit faster, right? It shows up and goes down a little bit faster than with the long version. What's the other one? What's the other mechanism for showing something to the user? Yeah, a toast, exactly. So before snack bar was available, we had something called toast. So if I comment this out, and instead I will say toast, and you will see that it has a very similar structure to the snack bar, right? So snack bar says make me a view. I'm passing kind of who is the parent, some text, and for how long it should be, and then it sets the particular action of what sort of icon I should have and so on, and then it shows it, right? With the toast it's similar. So there is a method called make text, and it takes yeah, let's use this version. So it takes the context of who is the parent view of this toast, what text should I show, and for how long, right? And you cannot show any icons here. So with the toast, it's just for text, right? So we will say make text, and I will use the same structure as before. Hello from post. And here I will say length, and I have to, I have a long or short version as well, right? So I will say do it for the long time, and then to actually show it, you have a method called show, right? So it is yeah, it needs a context. So instead of, oops, sorry, that was fine. So hello from toast. This one is not right. I cannot pass the view. I have to pass this. Yeah, because I am within main. Yeah, I can do this, and it will work. So there is a little bit of magic happening here. So I'm creating an inner class, right? So I have to have an inner class which will implement a single interface. So my class doesn't have a name. That's why it's called anonymous, but it implements this interface. So view Onclicklistener is an interface which you can check. So if I browse view Onclicklistener, it's a public static interface of type view.onClickListener. So it's actually part of the view. It only lives inside a particular view instance. And it has one method called onClick. So to have this implemented, I need a class which implements it, right? So I'm using kind of anonymous inner class which implements me this interface, and I'm overriding this onClick method by specifying what to do. This class, if I say this, it is this anonymous class which is created here, right? But I don't want to refer to this instance of that, because if I said new, I have a new instance of the class which doesn't have a name, right? And this refers to that instance of that class. If I want to refer to my main activity object, which this object lives inside, right? I have to refer to the other this by specifying that it's the outer context. So I'm saying main activity.this, which means it's the instance of my main activity. And this refers to that instance. Does it make sense? Yeah. And main activity is also a context. I have to pass context here, right? There is a slightly nicer way of doing it, because I don't need to pass entire main activity as a context. I can say get context, right? So if I say get context, context, yeah, I have to say get base context. Then I'm getting kind of a context of the application, and I'm passing that context in. The bottom line here is that for displaying a snack bar, I have to have a view hierarchy on which the view will kind of slide in and slide out, right? I need some view to attach it to. For the toasts, I have to have some context of where it belongs to. So it can be a context from the service, or it can be context from the activity, and it will work. So you can display a toast from within the service, from within something that doesn't have any UI. And that's useful because it allows you to debug what you're doing kind of internally inside your services without having the UI access. You cannot use snack bars from the services that don't have any view, right? Snack bar can only be attached to a view hierarchy, whereas the toast doesn't have to be. So now if I press this, you don't see it, but there is like a bit of a gray area around, and the toast shows up, right? So the toast is like a little, usually it's like a gray on the older Androids. It's kind of a gray bar which shows up and disappears, right? You might have seen it from some apps like debugging output. Normally you don't use it for the user, you use it only for yourself to for debugging purposes. So you have those two things. What else? How else you can communicate with yourself to see if something runs? So if I were to print myself a message, what would I use? Yep. That's right. So there is a log mechanism which allows you to print messages to the console, right? And then you have the I standing for information, D standing for debug, E standing for an error, and then you can display those things to yourself for the purpose of debugging the application. So for example, here what we could do, we could say, I want the debug message, which will be from my main activity. So this is the activity. This is like a tag, which will prefix all the messages that you want to search for. So you have like a category, what it is for, and then you have the actual message, right? So you can say, the fab was clicked, right? And we have to add the Android util log into the our packages that we use. We can delete, I mean not delete, but not use the snack or toast, redo it. And now when we click, now when we click, apparently nothing happens, right? But if we go to the if we go to our console, we see that, you know, a few milliseconds before, from, yeah, the fonts are small again for this part, so you don't see it on the screen, but if you do it on your own Android Studio, you will see that there is a debug message called D from main activity, which says fab was clicked. So the D stands for debug, it's this D here, and then the main activity is the prefix which I set here. So that's the text which prefixes my messages, and then you have the text which you set, right? So you can use it for debugging when things happen and how things happen. So it's kind of a useful tool. So if I now keep clicking, I will have, you know, this fab was clicked multiple times, right? All right, so let's stop it. You will see, you see here that when I, yeah, let's close it and open it again. Okay. So now Android Studio did something to my code, right? It kind of collapsed it. So if I expand it, I have this new view on Onclicklistener. I'm having a new inner class which implements this, and then I can collapse it to something like this, right? What would I use if I don't want to use anonymous inner class? How can I do this? So let's delete this logging. Let's go back to just the snack. And now I have the same behavior as before, but I'm still using this anonymous inner class. But I don't want to use anonymous inner class. I want to use a named class. How would I do this? So I would create a class called whatever, kind of my handler, right? Which implements view on click listener, right? And I have to have a method which is this. So I need a method, I need to implement this method. Yes. So I will format this. And then in here, instead of doing what I was doing, what I will do then? What I will pass here? I will pass an instance of my handler, right? So my handler doesn't have any constructor, which means it will have a default public constructor with empty parameter list. So I can always call this constructor by saying new my handler with empty parentheses. And now I have an instance of this handler attached to this fab. I can do it even more explicitly by saying I have my handler m, which is new my handler, right? Now I have an actual instance of that handler, and I can pass it to here, right? Why would I do this way, or why would I do this anonymous inner class way? Is this way more readable than the other way, or the other way is more readable? Yeah? Exactly. So if I were to reuse the same behavior for multiple buttons to print something, like print some debug message or whatever, then I would do it this way, right? So then I can reuse the field or the variable. Also, if this code was kind of complex, if this code was, 50 lines of code, right? And I would have it here, then I would lose track of what onCreate actually does, right? Because I would have those 50 lines of code inside onCreate, and then my logic of onCreate would be a bit lost. Here I kind of see clearly that I have a particular handler which the fab uses, and the behavior of that handler is specified somewhere else. If I'm using anonymous inner class, and if it's big, then it's less readable, right? But if it is small, it is actually more readable because it's in the same context, so it's already in there, right? So you can use it. So as you've seen, if we kind of go back, if I go back to the one without it, I don't have my own class. I have the anonymous class. No, I don't want that far. Okay, so if I go back to this, and again, I have to save it. I don't know how to refresh it so it actually does the editor magic, but it's doing it now. So what you see is it changed the syntax a little bit, because now it collapsed me this anonymous inner class to something that looks like this, right? What is this? Why I'm losing all this information and the editor is doing this for me? Well, you can say it's a little bit more readable. It removes all the noise which is associated with the logic of the handler, right? And it focuses on what the handler actually does, right? So that's one way of looking at it. The other way of looking at it is that from version Java.8, this is actually a Java syntax for this construction, right? So if we were to redo it in Java 1.8, what would you do is you would say fab set Onclicklistener. I'm passing a view, and I have a behavior, which is a Lambda expression, which is doing my snack thing, right? So I could do this. Oops. And it will work. And it will work in a minute. You see that the syntax of new Java is kind of what I had before with this one collapsed, right? I have to comment this out so I don't have the behavior twice. So let me comment this out first. And then you will also see that the compiler complains. The compiler complains that So if you highlight it, it says Lambda expressions are not supported by language level 7, right? So the default language which I have in Android Studio is Java 1.7. This is from Java 1.8, right? So it doesn't actually work because it goes beyond. I would encourage you to change the language into 1.8 and use 1.8. In the video about the threading, I'm kind of using that syntax, but it doesn't work and I don't change it in the video. But when you'll be watching the video, you can already change it and use the code with 1.8 feature. What do you need to change it? Well, you need to go to our wiki, and you will see Android project setup, and there is like one single item at the moment. So to enable Lambdas and other feature from Java 1.8, you have to change the default language version. So you copy those 4 lines of code, and then you go and in your Gradle script for the application. Oh, come on. You have your configuration file for your Gradle, and I'm using SDK 28. The minimum is 26. The application version is called 1. And then somewhere in the Android tab, you have to add those 4 lines. So inside here, you're adding that you want source compatibility 1.8 and target compatibility 1.8. When you save it, then you can resync your project to resync the setup for the compilers and for the build tools. And what will happen is the compiler will stop complaining and it will say, oh great, you're using the Lambdas, right? In fact, it says, it is already a Lambda, so I cannot replace it. What will happen if I uncomment this bit? It will complain that here I'm using kind of anonymous inner class, but I can replace it by the Lambda expression, right? So from 1.8, it will actually complain if you do code this way instead of doing the new Lambda expression way. So what's a Lambda expression? Well, Lambda expression is a piece of code which is of a particular structure. So you have parameter list, then you have the body, and this basically creates a function which has this body inside, right? So here I can have you can have some code. So this is like the body of the function, and this declares the function. If you have some parameters that the function is passed with, then you have to specify the parameters in the parameter list. So I could do something like this, right? And now I have a function which takes 1 argument and returns it incremented. So it doesn't have a name, but I can call it. So I can call it with 10 or 19, and it will return. It would return me an integer. So let's say value equals, right? Yes. So I don't specify the type. And then plus cannot be applied to a parameter for some reason. Yeah, I don't know why it complains. I will check. But the syntax is you have those braces which pass the parameter in, and then you can use this parameter as if you have normally with the functional parameters. So that's more or less the small change that we did into the original code, and like if I cut this off and rerun it, then it will work exactly the same as before using the Lambda syntax. It's a little bit less verbose. You don't have to type all the types, so it might be a little bit easier to read, and it's something you will see in the example code. So now if I press it, it works exactly the same way as before, right? All right, so let's have 10 minutes break, and I will check why the Lambda was complaining, and we meet 10 past 3. All right, so we finished with this question why arbitrary. So if I write an arbitrary lambda, so let's say I have a lambda which takes an integer, and I want to return an integer, right? So I have some method which says I have b equals a plus 1, return b, right? Why I couldn't call it with now say 19 and get 20 out, right? So if I say int value, I have this lambda thing, and it sort of doesn't really work. The reason is that Java lambdas are restricted to functional interfaces. So you cannot have arbitrary lambdas. You have to have lambdas which implement a particular interface, which has a single method, right? So for this to work, I would have to have an interface. So I would have to say I have an interface of some sort, of some type. I don't know, incrementer. And then this interface will have a single method. Let's say execute, or something like whatever you want to call it. And this takes an integer value and returns an integer value. Then if I have interface like this, I can cast my lambda to inc, and then I can sort of do this, right? So I can, for example, say I have inc m, and then I could say m is called with the particular number, right? So now I have an instance of this interface using the lambda expression, and then I can kind of call it. Well, that syntax doesn't work neither. So I can only pass it into the something that expects to get the instance of m of inc and then call it, right? But at least this syntax kind of specifies that now I have this, I have the actual instance of this lambda expression, right? But it normally cannot, you cannot have an arbitrary one. You have to have an interface. We will use those in a minute again. So how many of you feel okay, not with lambdas, but with the anonymous inner classes? Would you know how to write a callbacks for buttons or things using the listeners? So most UI elements, they have something that you, like this one has Onclicklistener, right? And if we go to the, if we go, for example, and search for button Android button class, I have the class, and then you have something called so the class hierarchy for a button is that it inherits from no, it is a kind of a base. Yeah, so it inherits from the view, and then the view has something called set. So if I search for listener, yeah, have lots of those. But okay, it has lots of listeners, right? So anything that happens within UI will have a listener. The one which responds for the click is called Onclicklistener, So if you search for Onclicklistener, so that's a simple code where we adding, you know, view Onclicklistener. It's the same way as we did for the fab, right? We have to implement a particular class. Sometimes you have something which is called long click. So you want to have a different behavior if someone long clicks on something or if someone taps on something, and you're doing it using the same mechanism, right? So are you okay with using those anonymous inner classes, or do you need more stuff about it? Check it at home. If you still have questions, then let me know, right? Or ask the tutors. This is a very common pattern of using the inner classes, and if you enable this Java 1.8, you can use those functional interfaces, right? So what I want to also talk today about is threading. So how many of you had multi-threading programming or used threads before? Yeah. And those of you who had C++, you never used threads? Or you did? Who had operating systems? I use pthreads, right? So who used C++ threads? A little bit? Okay. So why do we use threads? What are threads used for? Yeah?
You can have you can kind of run two sort of processes at once. It's not exactly the same as the two processes because they're threads.
Yeah.
And in Java you make a thread by, I'm not sure I understand whether you can either implement a runnable interface. Have a method called run, and that is automatically called.
Yeah.
Or you can use the thread class.
That's right.
And there's also a third way, I think anonymous. I think it started that using anonymous. I'm not 100% sure. I think there's just three ways to start threads in Java.
All right. So what I will do is I will reuse this button which we have, and I will do a little bit of stuff inside, right? So what I will do is I will say the threads have started. So when we press the button, we will have this text showing up, and then I will start some threads. So threads are useful for doing something concurrently, right? We want to do two things at the same time, or we want to display something to the user and at the same time fetch something from the network or whatever, right? And you often need to do two things concurrently. We have multi-core CPUs, so if you're only using a single-threaded applications, you're not using the hardware to the full potential. So in your application, you may want to do in one thread some rendering, in another thread maybe some AI or some image manipulation, and in the UI thread you will be doing something for the user interface, right? Android, when you start it starts with a single thread, which is the UI thread, and the UI thread manages all the interactions that we are having here, right? So me clicking on the items and me clicking on the button is handled by the single thread. So if I do something in this thread, it affects the UI, right? So for example, if I so let's see, I will do nothing, okay? I will do nothing in the thread after clicking the button. So you will see that it has to restart. So now if I click the button, what happens? Is it really nothing? Exactly, it changes the color. Like my click is registered on the button, and the button animates kind of a color change to tell me that I am pressing the button, right? So I'm pressing the button and the button reacts, right? And it happens in the UI thread because it gets the message that a user clicked the button, play this little animation or play the change of the color, and then call this this behavior. And because this behavior does nothing happens apart from the color change, right? So what will happen if I block here for a long time? So to simulate me blocking for a long time, I will say thread sleep for 5 seconds, right? And it complains that I don't implement the I have to catch the because while I'm sleeping, I may get the interrupt for to wake up. So I have to catch the, what was the exception called? Interrupt exception, right? So interrupted exception, and then usually you should tell yourself that something happened, right? You could have an empty block here, so you caught the exception, but you will never know that the exception happened, right? So often it is good practice to have something for yourself while you're developing the app to tell you that something woke me up or whatever, right? In this situation, that should never happen. But I'm still printing the stack trace into the console if something happens. So what will happen now if I run this up? What do you think? Yeah? That's right. So I'm pressing, what happens to the button? Nothing happens. So this time the color doesn't change, right? My UI is actually unresponsive, right? For 5 seconds, and then the first click should animate it, but it seems this gets the called first, and the animation actually either doesn't happen or happens after waiting for 5 seconds, right? So I don't actually see, yeah, I don't see it animating at all, right? If you sleep long enough, if I sleep for a very long time, you get something called okay, not now. Okay, sorry. So now I cannot interact with the app at all. I cannot open the menu. Oh yeah, that was good. So let's do it again. So what happens is there is a condition where the UI thread is blocked by a user doing something in the UI thread, and the app becomes unresponsive, and it's called ANR, Android not responding, right? It's one of the kind of exceptions which the developers should avoid. And what happens is you get like the operating system will kill your app, and it will show to the user that your app was not responsive and it was killed, right? And you want to prevent that. So you don't want to block a UI thread for an extended period of time. You see, my basic Java is not responding, right? Have you seen this error message on some of the apps? Okay, so that means the developers screw up. The developers are doing something which takes long time. Instead of doing it in the background thread, they're doing it in the UI thread, right? In the main thread of the application, right? You should never do that. So if you need to do something which takes some time, you should always do it in a separate thread, right? So I was patient enough and I kind of waited, but now I press this button and the app will again sleep for 50 seconds, which means I'm gonna get this thing again, and now I clicked close and up, right? Unintentionally, actually. So all the callbacks of your handlers or your things inside the onCreate are run in the main thread, in the UI thread. So do things you have to do and quit, like stop doing stuff, right? So what if I need to do something long like this in response to my button click? Well, I need a thread, right? I need a separate thread which will do that, right? So what we will do is we will create a new thread which will sleep for 50 seconds, right? And we will see how it works. So as you pointed out, there are multiple ways of doing it. One, the most basic mechanism is you have to extend a class called thread. So I have to instantiate again an anonymous inner class which will not have a name but will extend thread class, right? A thread is a class in Java, and this thread class will have a method. So this thread class will have a method called run, and this method run is returning nothing, and it takes nothing as an argument. And in this method we will sleep for 50 seconds. And then to start this thread, so now what happens is I have an instance of a new, I have new object, new instance of a class which doesn't have a name, but it extends thread class, right? So I could say thread t equals this, right? And now I have a reference to it. It's called t. I am using this type because otherwise it doesn't have a name, right? The new thread class doesn't have a name. Why this new class is different from thread? Because it is. I can have a new method here. I can have a public method called mama, right? Void f, right? And this method f has to have a body because we are not talking about abstract class. And this method, let's say, debugs something into my main activity. And it's like method f was called, right? Does thread has a method called f? No, it doesn't. But t has, right? I can say t.f. Technically, I kind of can't, because to do that, I would have to cast this t to the type which has a method f, but this type doesn't have a name. So I'm kind of a little bit in a, in a situation where from outside I cannot call f normally, but I can call f from here, right? I can say f, right? And that's perfectly fine. Like the instance has this method, but the thread doesn't, right? So if I were in a situation where I had to call method f from outside, I cannot really use anonymous class. I would have to have a named class, right? So I would say, okay, I would have to have a class. So like as we did with the interface, we would say I have a class called capital F, which extends thread. And then this class has a method f which does some things, and then it has a method run which does some things, right? And then in here I would say I have new f equals f, and then I could call ff, right? Then I can call it because I know what type it is, right? But to make things simpler, we don't need that. Let's say we don't need that. So we have the anonymous type. We don't need the f method. We're not using it. We just sleeping for some time. We don't need that declaration here. All right, so now I am at the point where I have the new instance, and I can name it. So I could say thread t equals this, but it just created the instance. It actually didn't create the thread yet, right? To really create the thread and run it, I have to call start method. So there is a method called start, and this method creates a thread and runs it with the body of this run method, right? I don't need to do it this verbosely, because I can call I can call start on the anonymous object, right? I can do this. So this new creates me a new instance up to here, and then I'm calling start on that new instance. Make sense? Great. So that's one way of doing it. And then if I now run the app, what will happen is every time I press the button, a new thread will be created, and this new thread will sleep for 50 seconds, and we will immediately come back to the UI thread, because I'm just creating a thread and quitting, right? So click, change of color, click, change of color, everything works, I'm responsive, the UI works all the time, but in the background, stuff is happening, right? Some things are kind of happening because I created new threads. When the thread finishes, when the end bracket of the run method is reached, the thread will be garbage collected. The thread will quit, right? So there is a different mechanism of doing that, which is similar, but instead of overwriting the thread class with having a new class which extends thread, I can reuse the thread class as it is and pass to it a runnable interface. So if I pass into the constructor something called new runnable, and this new runnable has a method run, and then on this thread I call, I'm missing, I'm missing closing round bracket for the, so now this is inside a thread. I'm passing this as a, let me rewrite it so it's more verbose. So if I say I have a runnable piece of code, which is R, which is new runnable, and this new runnable is public void run, and the code here, like the stuff that we have here is here, right? Then I can pass, I could say new thread R start. Make sense? So with this syntax, I'm passing R to the thread and then starting it. I don't need a variable, so instead of having a variable, I'm passing this code directly into the brackets here, right? And then I'm calling start. So it's a different syntax for the same thing. So now with Lambda expressions, we see that I can create this Lambda instead of using this syntax. I can do this syntax instead. And I don't need to write this declaration because it will know what method I mean. Oops. So it kind of it's a little bit simpler, right? And I can do the same here. So I can simplify it, and I can say my thread takes this. So you have less brackets and more verbose, more kind of succinct representation of the behavior, right? So this code is equivalent to this code if I copy and paste that bit into where this is, right? Make sense? Great. So now we have two mechanisms for starting a new thread. One where we overrode that thread class, and one where we didn't, but we kind of overrode the runnable interface, right? What is the advantage of doing the runnable interface? Yeah?
For example, Java doesn't support multiple inheritance. So if you have to extend if you're going to extend the thread, you can't extend something else. So if you need to extend something else, extend something and then implement
Runnable,
and
yeah.
then you can have
exactly.
And extend the class.
Yeah, exactly. So that's one really good point. You may have your own class hierarchy, and you've been already extending something, and it needs to run in a thread. Let's say you have AI manager, and which extends a manager, right? So you already extend some base class, and now you want it to run inside its own thread. You cannot extend a thread because you don't have two classes as base classes, but you can implement the runnable interface and then you can run it inside a thread. So that's one really good argument. The other really good argument is that, as you can see now, we can decouple the threads from what we want to run in the threads, right? So you could imagine some sort of a class which manages threads for you, and you pass the runnable to it, so then it will kind of run the jobs as the threads become available, right? And that's exactly what Java provides as well. So instead of doing this, much better way of doing the threading is to use thread pools, right? So if I search for some implementation of the thread pool, I can instantiate internally a number of threads which will be managing the jobs for me, and I can pass sort of a runnable to it to get it executed, right? So you can yeah, you can, and you can read about the, so if we go thread pool executor, no, that's not the one we want. Thread pool. So from Java 7 onwards, we have a number of things which allow us to manipulate those runnable things and have them executed in the background. So you have yeah, let me just see. We have the abstract, we have the scheduled, and yeah, the normal one is just how many? Yeah, so you can use one of the constructors to kind of manage the pool. So for example, the first one takes, okay, what is the pool size? What is the maximum pool size? How long you will keep the threads alive if they are not doing anything? And then what queue you want to use for the jobs, right? There are other classes which are useful for the pooling of the threads. So I don't want to spend too much time. It's just like a concept that you can use, and then you can sort of, so once you instantiated it and you have those threads behind, then you would say execute, and then you will pass this runnable and then it will kind of run the runnable for you, right? So instead of you creating the threads manually, you will kind of use some, threading pool executor to do this for yourself, depending on how many threads you need to manage behind the scenes. We will talk a little bit about it in the lecture, which is in 10 days, of how to do this. What I want to kind of stress today is the risks associated with threading, right? So if I have multiple threads executing concurrently, suddenly I'm losing some of the memory consistency, right? So in a sequential program, my code is executed line by line, kind of, and then if I'm doing something to the variables, the code below can see the changes which happened before that, right? So I have a particular sequential logic for the code which happens. But if I'm doing the threading, then that's not necessarily the case, right? So for example, if I, so let's delete this, let's delete this. We have the thread, and instead of sleeping for 50 seconds, how about we sleep for a random random duration, and the random duration will be it's a long final random duration. How do I generate a random long? Yeah, random. Is this a good way of generating? It's not kind of a security proper way of doing it, right? But for our purpose, we kind of don't care. We're not doing any security related things, so it's fine, right? So that will generate kind of a long number. We will not know how big it is. Like long can be 0 or can be what? What's the largest long? Yep. So it's kind of a large number, right? It has like 11 digits. What we need is we need to say Java util random, and we want, so next long. Yes, that's great. What we really want is yes, let's check the methods. So we have we don't have a method called next long which takes the bound, right, from 0 to the bound. We do have a next int which returns us the int. We need something between 0 and let's say 10 seconds. So 10 seconds is 10,000. So yeah, you could use modulo, or you could use int and then cast it to a long, right? So we will not lose precision if we use an int. So instead of using a long, we can say int, and the upper limit is 10 seconds, right? Yeah, Christopher told me to remind you not to use hard-coded values, right? If we see hard-coded values like this, or if we see hard-coded strings with quotes somewhere in the code, you will get told off. So you're supposed to have a constant. So let's do it properly. So in the main activity, we will say we have a final static long, and we call it delay, and we say that one is 10,000. Sorry. Okay, and then we will say here delay, right? That's a better way of doing it. And it complains because it is actually int, right? So now we're sleeping between 0 to 10 seconds. And then after we sleep, we will say view. No, we cannot say view. We have to get a reference. So what we want to manipulate this label. We have the labels called hello world. We want to change the text. How we can do this? We need a field. So the field will be a text view. So let's call it text view. And then same as we getting the fab here, find by ID, we will do the same for the text view. So we will say this text view equals find view by ID, and we have to find what is the what is this text view called. So how we do this? We go here and we see that it doesn't have an ID, right? So we will talk a little bit about it. Android Android ID equals and we call it message, text view message. Plus. All right, so now if I say RID, come on. Yeah, that looks good. I saved it. No, it doesn't see it. So why it doesn't see it? Yeah, it doesn't see it because it's not in the so I have the content, which is the whole thing, and I have the layout, which is kind of included internally. Let's not do it with the label. Let's do it with the single printout. Okay. So after I waited for a random amount of time, I will log something to the console, right? So I will say I will make it visible, and I will say hello from click number, and then I will add which click is it. So I will say plus click, and then I will have so let's delete that, I will have an integer which is called click, and it's initially 0. Whoops. Click. And then every time I click the fab, I will first I will say click plus plus. Okay, so now I have yeah, let's run it. Let's make the delay shorter. So let's make the delay 1 second. Okay, so the logic of our app is I have the fab, the button, I press it, I increment the which click was it currently, and then one of the threads will print the result for me, which is the number of the clicks that we have, right? So if I click once, and if I click second time, and if I go to the logcat, I will see I have hello from click number 1 and then hello from click number 2, right? If I click multiple times, you can see probably that I have 4 clicks, all of which says click from 8, right? So I clicked all together 8 times, and then I had multiple threads waiting a certain amount of time and printing me the result. So which thread will print the result is undeterministic because they are waiting kind of a random amount of time. So sometimes one will click print first, sometimes the other, right? So I have kind of, it's not really a race condition because I'm not really dependent on the value, but you can see that the threads printing it is kind of, I cannot control the order in which that happens, right? Which means I have to have a concept of controlling the state of the click somehow if I need to have a particular order of behavior specified like in the logic of the program, right? That makes sense? So if I cannot control the threads run with their own kind of scheduler, with their own way of doing things, and at the end they need to control something. Then you have 2 issues. First, you have the race condition. Second, you have the multiple threads potentially manipulating a variable, right? So in this case, I don't have 2 buttons which can start the click at the same time. But if I had, I could end up in a situation where one thread runs the click and another thread runs the click at the same time, and then I would have kind of the value incremented only once, not twice, right? So I have to take care of the shared state which the threads are using to make sure that it is consistent, that it behaves the way I want in the logic of the program. So of course this example is very contrived, but I just want to demonstrate two keywords. So the first keyword is called volatile, right? So what will this keyboard change? If I have it or not for the click? Yeah, so what do you think?
I used it before.
Yeah.
I don't think I have the correct understanding. I think it only allows for it to do one copy of that variable in memory at the same time.
Yeah, so what it is correct. So what it means is if I don't have it, right? There is RAM and there is threads which are run on the different cores. If I have multiple threads executing, they are very likely to be executing on the multi-core machine on multiple cores. So let's say I have now 4 threads executing in the 4 cores of my CPU, and I have a click value in the RAM. When the threads are accessing the click value, they have to cache it in the L1 or L2 cache on the CPU, right? So when the value is not volatile, they cache it and then they use the cache, right? And the multiple threads will see a different, potentially a different value, right? Because if I have 4 threads, 2 here and 2 here, the value, let's say, is 0. They all cached value 0, and now one thread added 1, right? So now I can see 1 here and 0, 0 here, right? If these two are sharing the same cache, they may see value 1 both, but these guys will see value 0, right? And now when these guys wrote something, this change is only local, right? Until it becomes global. But in the meantime, if these guys wrote something, let's say these guys wrote 1, then I have 1 here and 1 here, right? And then these guys wrote 2, so I have 2, 2, and 1, 1. And then at some point, the value gets reflected in the global state, right? So let's say they wrote 1 and 2 before these guys, and now these guys had 0, and they wrote 1. So now 1 gets to RAM, and 2 is lost, right? If you say volatile, what it changes is that now the cache, every time it is written, it's reflected into RAM, right? Yeah, so it's a write through to RAM, right? So if somebody now writes 1, the write goes into cache and into RAM, right? It doesn't necessarily invalidate the other caches, right? But the next person reading from, like, so if it is about the order, right? So without the volatile, what can happen is some things happen first. So I wrote 1, and I wrote 2, and then I wrote 1, and then the order in which this happens is not reflected in RAM, right? I can have 1 in RAM, or I can have 2 in RAM, right? It doesn't. It's non-deterministic, right? If I say volatile, then every time something happens, it happens into the RAM. So if this was written into RAM, and then this was written, then this will override whatever was written later, will override what was written first, right? And then if someone later reads a value, it will always see the value after the last read, after the last write. Whereas with the original one, you could have wrote something and then read, and you would read the old value, right? Because that is kind of non-deterministic. So this forces the writes to be ordered deterministically for reads and writes from RAM. How the threads are using the local cache, it's again unspecified, right? So specifying this makes some code a little bit more safe, but it doesn't prevent threads kind of writing twice and overwriting the value, right? So the logic is not guaranteed if you want kind of an atomic change, right? Because this is really like multiple operations. You have to read the value, make a copy, increment it, and write the value, right? So it's like 2 operations at the same time, and they are not done atomically. So one thread can read it, another one can read it, then this one increments it, this one increments it, and then this one writes, and then this one writes. So they both could see 0, and they both want to try writing 1, right? Even though it happened twice. So if you want to prevent this, volatile will not solve it. It can still lead to that problem. So then you have to use some locking mechanism, or you have to use like an atomic integer, right? So if you use an atomic integer, then it allows you to read and increment at the same time atomically. And then you will have a consistent state. So 2 threads cannot read and increment and write in multiple steps. They can only do it in one step. So if one did from 0 to 1, the second one cannot do from 0 to 1 ever again. It can only do from 1 to 2, right? So if you use, you know, an atomic integer, and, you know, have it, it's quite simple to use. You say new then in here, instead of doing this, you just say click increment So it basically changes from what it was by 1, right? And returns the current value, right? But if you don't need it, then you can discard it. And then you will have a safe kind of change. All right, so we run out of time. Some of this material is repeated in the lecture in 10 days. I just wanted to go a little bit more detailed with this. There is one small announcement. Those of you who want to meet with the tutor on Wednesday, please make so on the issue tracker. If we go to the issues, we will have a category for like Wednesday meetings. So make an issue that you want the tutor to be available between 10 and 12 in the, what is it, C007, and then the tutors will come. If you don't make it, then they will not be available, right? Otherwise, you can meet with tutors elsewhere if you agree on Discord with them directly, right? So the tutors' hours are kind of by default Wednesdays from 10 to 12 in C007, but you have to specify that you're gonna meet with them and discuss the project or whatever. Otherwise, they may not be there, right? If there is no issue, that means that they may not come, because there is no point them sitting there if nobody is coming, right? You can also tell them on Discord if you want to meet with them, and then the room is booked for 2 hours, so you can meet with them there. All right, so thank you very much for today, and then on Thursday we will talk a little bit about the UI.
So we do have a class on Thursday.
We will have a class on Thursday, yeah, like a normal lecture like today we had. Yeah.
Nothing tomorrow.